Welcome to another deep dive. And wow, you guys have sent in some really amazing stuff this time.
Yeah, this is some really fascinating material.
Yeah, excerpts from all sorts of early scientific texts focusing on magnetism and motion and...
Even early observations of animal generation.
I know, really cool stuff, right? Some real treasures to unearth here.
Absolutely. These sources offer a glimpse into a time when science was undergoing a profound transformation.
Oh, I love that. Tell me more.
A shift from reliance on ancient authorities to a new emphasis on observation and experimentation.
It's like we're going to be witnessing a scientific revolution in action.
Exactly.
I'm excited for this one. So, one of the figures we'll be exploring is William Gilbert,
Oh, yes, William Gilbert.
an English scientist who practically wrote the book on magnetism.
Literally.
Literally his work, De Magnete, published in 1600.
Groundbreaking.
Groundbreaking.
A true pioneer.
So tell me a little bit about him. What made him so groundbreaking? What was so special about him?
Well, he was challenging the established knowledge of his time. He was really,
The rebel.
yeah, a rebel in a way. In the preface to De Magnete, he passionately critiques those who blindly follow tradition and advocates for direct engagement with the natural world through observation and experiment.
You know, I love that perspective. I think that's so important, especially today. You know, we get so caught up in what we read online or, what we hear from other people.
Right.
But going back to the source material, going back to experimenting yourself, that's really how you learn and how you grow as a scientist and as a person.
Absolutely.
So what were some of the myths that Gilbert debunked through his work?
Well, one prevalent myth at the time was that garlic could demagnetize a compass.
What?
You can imagine the implications for navigation if that were true.
Oh my gosh, that would be chaos.
Total chaos. Gilbert meticulously designed experiments to test this
Okay.
and demonstrated that garlic had absolutely no effect on the magnetic properties of a compass.
Wow. So he was really testing those assumptions no matter how strange they might seem.
Exactly.
That's really cool. So he didn't just debunk myths, he made groundbreaking discoveries.
Oh, absolutely.
What were some of those?
Well, for instance, he was the first to systematically describe the Earth itself as a giant magnet.
Whoa.
This insight helped explain the behavior of compass needles
Okay.
and laid the groundwork for our understanding of the Earth's magnetic field.
So he was thinking big. He saw the entire Earth as one giant magnet.
Exactly.
That's an incredible leap of insight. And his work seems to have inspired other scientists to challenge conventional wisdom as well.
Absolutely.
Like who?
Well, one figure who was deeply influenced by Gilbert's emphasis on experimentation was Galileo Galilei.
Ah, Galileo. Now that's a name that everybody knows.
Precisely.
Even centuries later.
Like Gilbert Galileo was a revolutionary thinker,
Yes.
but his focus was on motion and the laws that govern the physical world.
Okay, so tell me about Galileo. What was so groundbreaking about his work?
Well, his book, Two New Sciences, was published while he was under house arrest.
Wow.
No less.
Really?
It delves into some fascinating concepts,
Right.
including the strength of materials and the motion of falling objects.
Okay. I can see how that would get you in trouble back then, challenging, the way people thought about the world.
It was a dangerous time for new ideas.
So Galileo meticulously explored the factors that determine the strength of materials.
He did.
How did he do that?
Well, he even used a thought experiment involving an infinitely long rope
What?
to explore the limits of strength and the structure of matter.
An infinitely long rope? How do you even conceptualize that?
It's a challenge, but that's the beauty of thought experiments.
Right.
You can explore concepts beyond the limitations of the tools available at the time.
So he was pushing the boundaries of scientific thinking even without, fancy equipment.
Exactly.
That's pretty cool. The ones that everybody knows about. His famous experiments with falling objects.
Of course.
That's where he really challenged Aristotle, right?
Absolutely. He was directly challenging Aristotle's claim that heavier objects fall faster.
So is that legend about him dropping objects from the Leaning Tower of Pisa, is that true or is that just a story?
Well, the legend may not be true, but his experiments definitively disprove a centuries-old assumption about how gravity works.
That's incredible. I understand he also used inclined planes in his experiments.
He did.
What did he learn from those?
Well, Galileo's inclined plane experiments were ingenious.
Okay.
By slowing down the descent of objects, he was able to make more precise measurements.
Okay, I see.
What he discovered was a precise mathematical relationship
Okay.
between the angle of the incline, the distance an object travels, and the time it takes to travel that distance.
Yeah. Okay.
This was a key step towards formulating the laws of motion.
So he was really uncovering the math behind the physical world.
Precisely. And to think he was making these groundbreaking discoveries while under house arrest.
It really shows his dedication to the pursuit of
Mm.
knowledge.
A true testament to the power of curiosity.
It's amazing. So we've gone from magnets to gravity and the laws of motion, all in the span of a few decades. It seems like science was really undergoing rapid transformation during this period.
It was a time of great intellectual ferment.
But there's another figure whose work we need to discuss. William Harvey.
Ah, yes, William Harvey.
He tackled a whole different realm of science, didn't he?
Indeed. William Harvey, a 17th century physician, revolutionized our understanding of the heart and blood circulation.
Okay.
His meticulous observations and groundbreaking experiments challenged centuries of medical dogma
Wow.
and paved the way for modern cardiology.
So his book, An Anatomical Disquisition on the Motion of the Heart and Blood in Animals,
Quite a title.
it was dedicated to King Charles I,
It was.
which I think speaks volumes about the significance of his work.
Absolutely.
So tell me what was so revolutionary about his discoveries.
Well, before Harvey, the prevailing belief was that blood was constantly being produced and consumed in the body.
Okay.
Harvey, through careful observation and experimentation, demonstrated that blood actually circulates in a closed loop,
Okay.
pumped by the heart.
That's a fundamental shift in understanding how the body works.
It was a paradigm shift.
So how did he manage to prove this concept at a time when medical technology was so limited?
Well, he employed some incredibly insightful methods.
Oh, I'm sure I bet.
He used ligatures to control blood flow in the arm,
Okay.
observing the effects on the veins and arteries.
Okay.
He also observed the flow of blood from a severed artery,
Oh, gosh.
noting the pulsating nature of the flow, directly linked to the beating of the heart.
Wow.
And through meticulous dissection,
Mm-hmm.
he was able to describe the function of the heart valves,
Okay.
those crucial gatekeepers that ensure blood flows in the right direction.
So it's amazing what he was able to accomplish with such limited tools,
He was a keen observer
relying primarily on his own observations and his deductive reasoning.
and a brilliant experimentalist.
It sounds like he was not just a skilled anatomist, but a brilliant detective, piecing together clues to solve the mystery of blood circulation.
His work was a masterpiece of scientific investigation, combining meticulous anatomical study with clever experimental design.
And it had profound implications, not just for medicine, but for the advancement of science as a whole.
Absolutely. It laid the groundwork for a whole new understanding of physiology
That's incredible.
and inspired generations of scientists to come.
It's amazing to think about the impact that these early scientists had on our understanding of the world and how they really shaped the way we think about science today.
They were true giants,
They were giants, they were
Yeah.
pioneers, and their legacy continues to inspire us.
and their work remains relevant even in the 21st century.
Well said. So let's take a quick break, and when we come back, we'll delve even deeper into the fascinating world of William Harvey and his exploration of animal generation.
I can't wait.
Stay with us. It's incredible to think how much Harvey was able to accomplish without, all the tools and technology that we have today.
It really is remarkable.
But his work didn't stop with the heart. He also delved into the mysteries of animal generation.
He did.
And if I remember correctly, it all started with a talking parrot.
That's right. Harvey's observations of his pet parrot, particularly its ability to mimic human speech,
I can just imagine.
sparked his curiosity about the nature of reproduction and the differences between the sexes.
Oh, that's interesting. Yeah, I can see how a talking parrot could lead to some, deep philosophical questions about the origins of life and
Absolutely.
the nature of being.
It's a fascinating starting point.
It is. But Harvey, being the meticulous scientist that he was, didn't just, ponder the parrot's vocal talents. He took his inquiries a lot further, didn't he?
Oh, he did. He conducted extensive studies of the reproductive anatomy of various animals
Okay.
with a particular focus on chickens.
Chickens. Interesting.
He was fascinated by the formation of eggs and the development of embryos.
Okay, so he was moving from the macro level, the heart pumping blood throughout the body, to the micro level. The intricate processes of reproduction and development, that's quite a range.
Harvey's curiosity knew no bounds.
And his observations of chicken embryos led him to consider the different theories
Yes.
about the
The efficient cause of generation.
deficient cause of generation.
Well, that were circulating at
Now,
the
this
time.
was a hot topic back then.
It was a question that had fascinated philosophers and scientists for centuries.
Okay, so we're talking about the fundamental question of what triggers the development of an embryo.
Exactly. The spark that ignites the creation of a new life.
Okay, and it sounds like there were some competing theories about this back then.
There were indeed. One prominent theory came from Aristotle,
Oh, Aristotle, of course.
who believed in a concept of a prime mover,
The prime mover, okay.
a cosmic force that set all natural processes in motion.
So Aristotle was suggesting that there was this kind of universal force, a prime mover, that orchestrated the development of embryos.
Precisely.
How did he see that force working in practice, though?
Well, he believed that this prime mover acted through a chain of subordinate causes,
Okay.
with the male semen serving as a key intermediary,
Okay.
imparting form and motion to the matter provided by the female.
So he saw the female contribution as being primarily passive?
Yes, providing the material substance, while the male provided the active principle that shaped and animated the embryo.
Okay, so in Aristotle's view, the female was like a vessel,
In a sense, yes.
and the male provided the blueprint and the energy for development.
That was his framework.
Was there any room for a more equal partnership between the sexes in his theory?
Not really. His framework was very hierarchical,
Okay.
with the male playing a dominant role in generation. This view, of course, would be challenged by later scientists,
Including Harvey.
including Harvey himself.
Yeah, I can see how that would raise some eyebrows. So if Aristotle was all about this cosmic prime mover, were there other scientists who had different ideas about the efficient cause of generation?
There were indeed. Another prominent scientist of the time, Fabricius,
Okay.
proposed a different theory.
Oh.
He focused on the role of the seminal fluid,
Okay.
believing that it contained a vital principle
Okay.
that was responsible for shaping and animating the embryo.
So instead of a cosmic force, Fabricius was suggesting a more tangible physical agent,
Exactly.
the seminal fluid as the driving force behind development.
Precisely. He saw the seminal fluid as carrying a kind of blueprint for the new life,
Interesting.
guiding its development from the very beginning.
So Fabricius was taking a more hands-on approach,
He was.
looking for answers within the biological mechanisms themselves.
Exactly.
It sounds like he was on the cusp of something that we might recognize today as genetics, even if he didn't have the concept of genes yet.
He was a pioneer in his own right.
He was. But where does Harvey fit into all of this? What were his thoughts on these competing theories?
Well, Harvey, as always, grounded his views in his own observations.
Of course.
He conducted meticulous dissections of chicken embryos,
Okay.
carefully documenting the stages of development. He was particularly intrigued by something called the hyponemic egg.
The hyponemic egg? What's that?
It's an egg laid without fertilization.
Oh, so what we would call an unfertilized egg today.
Exactly.
Okay. And I'm guessing this presented a challenge to some of the existing theories about the efficient cause of generation.
It did indeed. Aristotle, for instance, believed that these unfertilized eggs possessed a vegetative soul,
Okay.
which allowed for growth and development,
Okay.
but not true animation.
So he saw them as a kind of incomplete life form.
Yes.
Lacking the essential contribution of the male semen.
That was his view,
So he was drawing a distinction between plant life.
which he associated with the vegetative soul,
Okay.
and animal life, which he believed required the animal soul activated by the male contribution.
I see a hierarchy there.
There was a clear hierarchy of souls in his view.
But did Harvey's observations support this hierarchy?
Not entirely. While he acknowledged the importance of both the male and female contributions in generation, his observations of developing embryos, both fertilized and unfertilized,
Mm-hmm.
led him to question the idea of a passive female role.
Okay.
He saw the female contribution as equally vital,
Okay.
providing not just the material substance, but also a force of her own,
Okay.
a generative power that worked in conjunction with the male contribution.
So he was pushing back against that hierarchical view of reproduction,
He was.
recognizing a more equal partnership between the sexes.
Precisely.
That's a significant departure from Aristotle's perspective.
It was a bold step.
It was. But if he wasn't fully on board with Aristotle's prime mover or Fabricius's focus on seminal fluid, what did Harvey think was the driving force behind the development of the embryo?
He was particularly fascinated by what he called the primordium,
The primordial.
the first recognizable structure that emerges in the developing embryo.
Okay.
He observed the beating heart, the formation of blood vessels, and the gradual differentiation of the various parts of the body.
Mm-hmm.
And he saw these as evidence of a force inherent within the egg itself, a force that drove the process of development from within.
So he was shifting the focus from an external force to
Yes,
something internal, something within the egg itself that guided its development.
exactly.
That's an intriguing concept.
It was a radical departure from the prevailing theories of his time.
It was, and it laid the groundwork for a more modern understanding of embryology,
Precisely.
recognizing the embryo as a self-organizing system.
Guided by an internal blueprint that unfolds over time.
And to think he was arriving at these insights through careful observation and dissection without, microscopes or any of the advanced tools that we have today.
It's a testament to his powers of observation and deduction.
It really is. His
Yeah.
work on animal generation, like his work on the heart,
Yes.
marked a significant turning point in scientific thought.
Absolutely.
A move away from blind acceptance of ancient authority towards a more empirical, evidence-based approach.
It was a crucial step in the evolution of science.
It was, and he wasn't afraid to challenge those long-held beliefs,
He was a true pioneer.
even when they came from someone as revered as Aristotle.
He let the evidence guide him.
But I'm curious, did he limit his investigations to chickens and other animals? Or did he also apply these ideas to human reproduction?
He did delve into the realm of human reproduction.
Okay, and how did that go? So we've seen how Harvey challenged traditional views on animal generation based on his meticulous observations of chicken embryos. Did he extend these investigations to human reproduction as well?
He did, and his findings led to some groundbreaking yet controversial conclusions.
Okay, such as?
Based on his anatomical studies, he questioned the long-held belief that women emitted a female semen during intercourse.
Whoa, challenging a core tenet of reproductive theory at the time. So what led him to that conclusion?
While Harvey's meticulous dissections of female deer
Okay.
revealed no structures analogous to the male tests,
Okay.
he also considered anecdotal evidence, noting that many women reported no sensation of emission during intercourse.
Oh, interesting.
This combination of anatomical and experiential evidence led him to challenge the prevailing dogma.
It's fascinating that he was synthesizing knowledge from multiple sources.
He was.
Anatomy observation, even personal accounts.
Exactly.
To arrive at a new understanding of human reproduction. He truly was a pioneer in scientific methodology.
His rigorous approach, applied across diverse subjects like the heart-blood circulation and animal generation, exemplifies the power of observation, experimentation, and critical thinking in advancing scientific knowledge.
It's remarkable how these early scientists were reshaping our understanding of the world, pushing the boundaries of knowledge, despite the limitations of their time. Looking back, it's clear they were operating during a period of immense intellectual upheaval.
Absolutely. This era, often referred to as the scientific revolution, marked a profound shift in how knowledge was acquired and disseminated.
For centuries, European thought had been dominated by the teachings of ancient authorities, particularly Aristotle. His pronouncements on physics, astronomy, biology, virtually every other field of knowledge were considered almost sacred.
Aristotle's word was law.
But then something shifted. What sparked this scientific revolution?
It was a confluence of factors.
Ugh.
The Renaissance, with its rediscovery of classical texts, sparked a renewed interest in learning and inquiry. The invention of the printing press allowed for the wider dissemination of knowledge,
Oh yeah, that makes sense.
breaking the monopoly held by religious institutions and universities. Exploration and discovery of new lands and cultures challenged long-held assumptions about the world. And perhaps most importantly, there was a growing willingness to question authority and to test established knowledge through direct observation and experimentation.
So it was a perfect storm of intellectual curiosity,
That was
technological advancement, and a bold spirit of inquiry. And our three protagonists
Gilbert, Galileo, and Harvey.
were right at the forefront of this revolution.
Precisely. They embodied this new spirit of scientific inquiry. Gilbert, with his meticulous experiments on magnetism, Galileo challenging Aristotle's theories of motion with his inclined planes and falling objects, and Harvey revolutionizing our understanding of the heart and blood circulation.
Yeah.
They were all pioneers in their respective fields, laying the groundwork for modern science.
Their work wasn't just about making individual discoveries, it was about changing the very way science was done. They shifted the emphasis from blind acceptance of ancient authority to a more empirical, evidence-based approach.
Exactly. They demonstrated the power of observation, experimentation, and mathematical reasoning in unlocking the secrets of the natural world.
It makes you wonder what they would think of science today with our powerful microscopes, telescopes, and the ability to explore the universe at the subatomic level.
I imagine they would be astounded by the progress we've made.
I think so.
But I also believe they would recognize the same spirit of inquiry,
Yeah,
the same drive to explore and to understand that motivated their own work.
that's a really nice thought. It's inspiring to think that the scientific knowledge we take for granted today is the product of centuries of effort of countless individuals driven by a thirst for knowledge and a willingness to challenge the status quo.
It's a testament to the enduring power of human curiosity,
Yeah.
the insatiable desire to understand ourselves and the world around us.
Well said. This deep dive has taken us on an incredible journey through the history of science, showcasing the brilliance and courage of these early pioneers. It's a powerful reminder that the quest for knowledge is an ongoing process, an adventure that continues to unfold with every new discovery.
And perhaps the most important takeaway is this.
Okay.
The most essential tool for any scientist is not a fancy instrument, but a curious mind. So keep asking questions, keep exploring, keep pushing the boundaries of what we know. Who knows what mysteries you might unravel?
What a fantastic thought to leave our listeners with. Thank you for joining us on this exploration of scientific history. We hope you've enjoyed this deep dive. And remember, the journey of discovery never truly ends.